Alright, continuing lesson 6.7, we're going to keep going a little bit with the probability. In this one, example 3, we're going to use our experimental probability to make predictions. So, today you attempted 50 free throws and made 32 of them. Use experimental probability to predict how many free throws you will make tomorrow if you attempt 75 free throws. So today, we attempt 50, so that's our total that we try. Of that 50, we make 32 of them, so 32 successes. Now this is experimental probability because we don't know all of our possible outcomes. It's based on repeated trials. So, that being considered, to consider what we're going to predict what we're going to get tomorrow, we know that we're going to attempt 75, so a total of 75 possibilities, and we need to figure out how many of those we're expecting to actually get in. So we're going to solve this. It's really just a proportion. We can do it a couple different ways. I'm going to go ahead and cross multiply. 32 times 75 is 2,400. X times 50 is 50x. Divide by 50, divide by 50, and my answer gives me x equal to 48 successes. So if I keep it the same rate as I did today, tomorrow when I do 75 free throws, I should be able to make 48 successful baskets. Now if I attempt 150 free throws, similar concept. I'm going to start with my experimental probability from today where I found I got 32 out of 50 successful. And instead of over 75, now it's going to be over 150. I could cross multiply, but don't forget, sometimes there's going to be shortcuts. 50 times 3 is 150. 32 times 3 is actually 96. So I can get my answer just like that. 92 successes should be anticipated if I'm going to shoot 150 free throws. So if you were in some kind of competition and you wanted to guess how many you're going to get correct, it would be worthwhile to try it on your own, make a few trial experimental probabilities first, and use that probability rather to predict what you're going to do in the real contest. Alright, now here's something a little bit separate, similar concept but different, same grouping, like it has to do with probability, but it's a different term, and this is known as odds. Okay, and it doesn't mean like an odd or even number. We're going to be talking about odds, and what that is that's my chances of winning compared to your chances of winning. So when you go to the carnival and you play Big Spin the Wheel and you pick a number, it's what your chance of winning is, not out of the total, but what your chance of winning is compared to what the opponent's chance of winning is. Okay, so it says here, when all outcomes are equally likely. That's important. The ratio of the number of favorable outcomes to the number of unfavorable outcomes is called odds in favor. Odds in favor of an event. And what that is, like we said, that's what your favorable outcomes are compared to your unfavorable. So what you want to get compared to what you don't want. So what you want over what you don't want. Notice, we're not talking about totaling things up here. This is just what you want and then what you don't want. There's no totals. That's probability. That's what you want out of the total. This is different. It's called odds in favor. And we're just going to simplify it and call it, what are your odds? Okay? Now there's two different kinds of odds in favor, odds against. The reason we can simplify is because we aren't going to be focusing on odds against. And that's what this here is. It's the opposite. It's the ratio of unfavorable to favorable. We're only going to be focusing on odds in favor, so you can keep that in mind. So I'm just going to refer to it as odds. Let's try one. Example 4 says, suppose you randomly choose a number between 1 and 20. So this is our event, or this is our situation, randomly choosing a number between 1 and 20. What are the odds in favor of choosing a prime number? So we need to figure out favorable over unfavorable. And with that in mind, first we need to know our odds in favor of choosing a prime number. We need to know what the prime numbers are. So between 1 and 20, the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19. Remember, a prime number is any number divisible only by 1 in itself. So now that we've listed our prime number, our odds in favor of choosing a prime number, how many favorable outcomes do we have? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 favorable outcomes. How many unfavorable outcomes do we have? How many numbers are not prime or composite? That would be 12. So here we could go ahead, then we're just going to simplify this. We're going to get 2/3. So our odds in favor are 2 to 3. And what that means is for every 2 times that I win, the person I'm competing against would be winning 3 times, okay? Like the opponent. So if you play like a game of cards, maybe if you're watching poker or something like that, some kind of card game, it's your chances compared to the dealer's chance. That's what your odds are, okay? Now letter B, I'm going to scratch it out because I said we aren't doing odds against, but I'm going to make a different one. Instead of this, we're going to do what are your odds in favor of choosing a number, we'll say between, but not including, 3 and 10. So then first we want to figure out what are all of our favorable outcomes. What are all the numbers between but not including 3 and 10? That would be 4, 5, 6, 7, 8, 9. These are our favorable outcomes. These are the things between 3 and 10, but it doesn't include those ones because they specified that. Alright, so favorable outcomes are how many you want to get. 1, 2, 3, 4, 5, 6. We have 6 favorable outcomes. Again, we're working between 1 and 20 as our situation that we're covering. So the odds in favor of choosing a number between 3 and 10, but not including those two, would be 6 to 14. And the reason is there's 6 favorable outcomes, that's 4, 5, 6, 7, 8, or 9, and there's 14 unfavorable outcomes. Those would be 1, 2, 3, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay? Let's try one more and then we'll be set. How about odds in favor of choosing an even number? Okay? Odds in favor. So how many favorable outcomes do we have? What are our favorable outcomes? Our favorable outcomes are any even number. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And there's a total of 10 of them. We have 10 favorable outcomes over the things we don't want are unfavorable. Our unfavorable outcomes would be any odd numbers. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. We have 10 of those. So when we simplify, it's going to be 1 over 1, and we just want to keep it as a ratio. So you could keep it 1 over 1, or you could write it with the colon 1 to 1. Okay? Or we learned you could even write it like this, 1 to 1. Any of these would work, but we want to realize that the chances of us choosing an even number, we have for every 1 time that we win, we'll probably lose ones. And that's what that means. It's not saying how many chances you have out of the total, it's what your chance of winning is compared to your chance of losing. Favorable to unfavorable. Okay? And again, this is it shows up a lot in any kind of like gambling of sorts or carnival game, things like that. Often they don't post your odds at a carnival game, but if you look on the back of an instant lottery ticket in the bottom corner, they'll have something written like 1 to like 100,000 or whatever it may be, and that's you have 1 chance of winning for every 100,000 chances that you'll lose. This is not out of the total, your chance of winning. So this is you win, yay, to they win, which is sad times. But obviously with an instant lottery ticket or something, maybe a higher lottery would have a one like this, your chance of winning is going to be pretty small, and the chance of you losing or the other people winning is pretty high, the dealer. Okay? One last thing I want to point out is right here. If we look back at our odds in favor, here we had our favorable over unfavorable 8 to 12. Here we had 6 to 14. Here we had 10 to 10. If we total these, 8 plus 12 is 20. 6 plus 14 is 20. 10 plus 10 is 20. Our total is always going to come to what our total options were. So total is not part of the problem. It's favorable over unfavorable, but the two of them added together should equal all of the possible outcomes. Okay? Again, we're going to do more hands-on stuff and some practice applications, but these are the key notes that we need to understand probability and odds. Thanks, guys.